Hi students, hello everyone. I hope everyone is doing great. Today we are going to solve one of the JE question which is given in April shift page 2. This is page 2 question, April shift. The given question is if A is equals to 2 minus 1 1 1, then sum of the diagonal elements of A power 13, we have to find the sum of the diagonal elements A power 13 which is equals to 3 power n, then n is equals to, this is what the given question. The sum of diagonals of A power 13 is equals to 3 power n, then we need to find the value of n. This is the given question. Sum of the diagonal elements is nothing but trace of A power 13. You can solve this question in two ways. First one is very lengthy procedure and calculative procedure, that is finding A square, then A power 4, then A power 8, then A power 8 into A power 4 which gives A power 12. Again we have to multiply A power 12 with A which gives the final answer. Like first solution, first type is, first we need to find A square, then A power 4, then A power 8, then we need to multiply A power 8 and A power 4 which gives A power 12, then A power 12 into A is equals to A power 13. This is lengthy procedure and very calculative procedure. And another method is we can solve this question by using Cayley-Hamilton theorem. So let's discuss about what exactly is Cayley-Hamilton theorem. For every square matrix, or every square matrix satisfies a specific polynomial equation. Every square matrix satisfies a polynomial equation A minus lambda I is equals to 0, that implies P of A is equals to 0. This is Cayley-Hamilton theorem. By using Cayley-Hamilton theorem we can answer that particular question. Now we go back to the question again. Apply Cayley-Hamilton theorem for this question. Lambda A is nothing but 2 minus 1 1. Next lambda I is nothing but lambda 0 0 lambda, that is equals to 0. Next 2 minus lambda minus 1 1, this is 1 minus lambda, that is equals to 0. Find the det of this one. If you find the det of this one, 2 minus lambda into 1 minus lambda minus of minus 1 is equals to 0. This is the det value. Then 2 into 1 is 2, minus 2 lambda minus lambda plus lambda square plus 1 is equals to 0. Final specific equation is lambda square minus 3 lambda plus 3 is equals to 0. We call this one as characteristic equation. We call this one as CH, characteristic equation in Cayley-Hamilton theorem. Now lambda square minus 3 lambda plus 3 is equals to 0. If you find the roots of this equation, sum of the roots lambda 1 plus lambda 2 is equals to 3, and product of the roots is lambda 1 plus lambda 2 is equals to 3. Sum of the roots is also equals to 3, and product of the roots is also equals to 3. Finally what we need to find is sum of the diagonal elements of A13. Sum of the diagonal elements of A13 are nothing but lambda power 13, lambda 1 power 13 plus lambda 2 power 13. These are the sum of the diagonal elements of A13. That is what we need to find. And also given that this is equals to 3 power n, what we need to find is we need to find the value of n. Once you get lambda 1 plus lambda 2 is equals to 3 and lambda 1 plus lambda 2, sorry, this is one is sum of the roots and one is product of the roots. This is product of the roots. Lambda 1 into lambda 2 is equals to 3. Once you get these equations, then you can find lambda 1 square plus lambda 2 square in an easy way. So lambda 1 square plus lambda 2 square is nothing but lambda 1 plus lambda 2 whole square minus 2 times of lambda 1 into lambda 2, that is equals to 3 square minus 2 into 3. This value is nothing but 9 minus 6, that is also equals to 3. Now we will try to find lambda 1 whole cube plus lambda 2 whole cube. Formula is lambda 1 plus lambda 2 into lambda 1 square plus lambda 2 square minus lambda 1 lambda 2. This is the formula of lambda 1 cube minus lambda 2 cube, lambda 1 lambda 2. This is the formula. Now this is equals to lambda 1 plus lambda 2, sum of the roots is equals to 3. So 3 into lambda 1 square plus lambda 2 square is 3 minus lambda 1 into lambda 2 is also equals to 3. The total value is 0. So lambda 1 square plus lambda 2 square is equals to 0. From this I can conclude lambda 1 whole cube minus is equals to minus of lambda 2 whole cube. Lambda 1 whole cube is nothing but negative sign of lambda 2 whole cube. Since from this one what we can write? From this one we can write lambda 1 into lambda 2, that is equals to 3. Do squaring on both sides, cubing on both sides. For this, cubing on both sides, then we get lambda 1 cube into lambda 2 cube, which is equals to 3. Since lambda 1 whole cube is nothing but negative sign of lambda 2 whole cube, so substitute that one, minus of lambda 2 whole cube. This is 3 cube 27. This is 3 power 3 lambda 2 whole cube, which is equals to 27. This total is lambda 2 whole power 6 is equals to minus 20. We can write this one as lambda 1 whole power 6, which is also equals to 27. Once we get this one, remaining thing is easy. See here, from this equation again what we can write is, since lambda 1 whole cube is equals to minus lambda 2 whole cube, take power of 4 on both sides, then we get lambda 1 whole power 12 is equals to lambda 2 whole power 12. 4 is even number. If you do the power negative, minus 1 whole power 4 is nothing but positive 1. So minus of lambda 2 whole cube whole power 4 is positive. This is one more result which will help us to find lambda power 13 plus lambda 2 power 13 is equals to 3 power n. Now lambda 1 power 13 plus lambda 2 power 13 is equals to, we can write this one as lambda 1 into lambda 1 power 12 plus lambda 2 into lambda 2 power 12. Since lambda 1 whole power 12 and lambda 2 whole power 12 both are equal, so lambda 1 into lambda 1 whole power 12 plus lambda 2 into lambda 1 whole power 12, because both are same. Next you can take lambda 1 whole power 12 common, you get lambda 1 plus lambda 2. This total is equals to 3 power n. This is 3 power n and this is also equals to 3 power n. Lambda 1 value is 27. This is lambda 1 whole power 6 is 27. So that is nothing but 27 whole square. If you do squaring on both sides, then you get lambda power 12 is equals to 27 whole square, and lambda 1 plus lambda 2 value we already know that value is 3, sum of the roots. So 3 power n is equals to, you can write 27 as 3 cube whole square into 3. The total is equals to 3 power 7. 6 plus 1 7. Since bases are equal, powers must be equal, so n value is equals to 7. 7 is the correct answer for this particular question. I hope you enjoyed this video a lot. If you enjoyed this video, please like, share and subscribe. Thank you for watching this video. Have a nice day. So 7 is the final answer for this particular question.